Okay, so we were zooming in on the y-axis, and we were zooming in a lot, right? We were looking at smaller and smaller and smaller and smaller little part of the x-axis right above x equals 0, and now zoomed in on that. And so what is this? This is 6 times 10 to the minus 64th of length, right? And I think, did we say 1, 2, 3, 4? That's 6, so maybe that's 5 feet now, okay? So maybe that's 5 feet up to 6 times 10 times to the minus 64. Maybe on your screen that was 5 centimeters. So let's go with that because it said on your screen. So let's go with a distance of 5 centimeters. And if that's 5 centimeters, where is 1? Right? That's what we're asking. How high up is 1 if that's 5 centimeters? Okay, let's do it. So the number we have is 6 times 10 to the minus, tell me? 64. Okay. So here's that number. And so the first thing I'm thinking about I want to do is I want to know how many of those fit into the distance of 0 to 1, right? The distance of 1. How many of those fit into that? And how would I find that? Yeah, if I take 1, I'm taking 1, a length of 1, I want to see how many of those fit into 1. So I'm going to do 1 divided by that. Okay, so just a few. Okay, just a few. 1.67 times 10 to the 63rd of those fit into the distance from 0 to 1. And then each one of those was how long on your screen that we say? 5 centimeters. So I got the number of them is that, and then now in centimeters. So here we are in centimeters, and I think most of the other units we're using are in kilometers. So how would we get kilometers? Well, let's do meters first. So if it's this many centimeters, how many meters? 1/100th of that, or you would divide that by 100. Now we're talking about that's meters. And then, so I can put parentheses around that to mean meters. And then I can divide that by 1,000 to get kilometers. And I think yesterday at the end of class I put 100 when I was converting to kilometers. From meters to kilometers is a factor of 1,000. Okay, and so that brings up a point. If I am a math genius, it's true, but I make mistakes. I make little, mistakes. Usually like 2 or 3 a class. I'm depending on you to, as soon as you think it's a mistake, raise your hand. So there's not many of you confused for a minute or 2 or 3 minutes staring at that going like, I think that's supposed to be that, all right? So don't hesitate. Let's just nip things in the bud, right? So we'll just get those mistakes cleared up right away so that there's not this cloud of confusion for people, okay? And if that's you, then speak up, okay? All right, so now we've got kilometers. We've got kilometers here. And I think one of the things they wanted to say was light years. How many light years? Is that one of the ones you had to do? From 0 to 1, how many light years is that? And light year, is that a big distance or a small distance? Big distance, right? Big distance, right? Okay, all right. So how many kilometers is a light year? Is that here somewhere? Right there, right? 9.454 times 10 to the 9th kilometers is 1 light year. So I've got a bunch of kilometers, and I want to know how many groups of 9.45 times 10 to the 9th kilometers fit into mine. So what am I going to do? Divide. So I've got this number of kilometers, and I want to, oh no, what happened? Okay, I guess it's right. And I want to find out how many of that many kilometers fit into that. So we'll do divided by 9.454 times 10 to the 9th. How many light years from 0 to 1? If 5 centimeters is the distance from 0 to 6 times 10 to the minus 64, then how many light years of distance is it from 0 to 1? 8.8, just a few, 8.8146 times 10 to the 48 light years. Is a light year a big number? What about here? Is light year a big number here? Extremely, extremely small compared to the distance from 0 to 1. Right? Compared to the distance from 0 to 1, a light year is extremely small. Like what we call infinitesimally small. Okay? So how far is it across the known universe? Is that in light years? Is it in there somewhere? Yeah. Distance across the known universe. 4.6 times 10 to the 10th light years. So now I have a number of light years, and I want to figure out how many chunks of 4.6 times 10 to the 10th fit into that. Okay, the distance from 0 to 1, when we were looking at 5 centimeters being that distance to 6 times 10 to the minus 64, if that's 5 centimeters, then how many trips across the universe does it take to get to 1 from 0? A couple. 1.916 times 10 to the 38th trips across the universe. Oh, I hate that. Don't do that. Okay, we're back. Yeah, so is the width of the known universe a big or a small number? So the distance across the known universe. Well, when you're talking about this situation that we came up with of getting from 0 to 1, then again, the distance across the known universe is an super, super, super small number. So that's kind of the point of this problem. Okay, does that kind of, so lots of you chose 2. Does me talking through that much of it helps clear some things up? Is there a follow-up question that I maybe didn't address? Yes, please. Okay. Yeah, I just left them off. They're not necessary, right? I can do it, but so that shouldn't change anything. Yeah. That won't change anything. That's the same number that was there before, right? Yeah. Okay. Other questions? Follow-up questions on this one, number 2. Yeah. I said that on your screen, maybe it was 5 centimeters. You were supposed to measure on your screen the distance from 0 to 6 times 10 to the minus 64th, and then do it based on that. So everyone could have a different final answer. Yeah. Other questions? Okay, cool. So that takes care of chapter 1. And then you had to read chapter 2 for today. So let's do Top Hat. Chapter 3. And variables. So let's talk about Clara, the calculus cow. She's been tied to a silo. The silo has a radius of 2 meters, and she's tied to it by a rope attached to the westernmost spot on the silo, and the rope is just long enough for her to reach the easternmost point of the silo. So this problem was find the parametric equations for the path that she could walk, always keeping the rope taut, and then find the area of the region she can graze in. But we just want to use this as practice ground for variables, constants, and parameters. So there she is. There's Clara the calculus cow. Can you see the silo? It's very faint gray. Can you guys see in the back the silo? We're going to change the color of the silo. You see that gray circle? Okay. Yeah, so the gray circle, you're looking down on the silo, and the blue is the rope. The rope is tied to the westernmost point, and it's just long enough for her to reach the easternmost point. So what we want to do is just take a couple minutes, define constants in this situation, and use parameters for constants whose values do not know, and then define variables in the situation. State the intervals over which they vary. See what we come up with. So there's lots to talk about here. So again, what you're given here is that silo has a radius of 2 meters, okay? So how many constants can you come up with? Use parameters for the ones whose values you don't know. And then how many variables can you come up with? Okay, so yeah, you're going to discuss, but you have to be writing, okay? So writing, make a list for yourself. Okay, so I came up with two constants and one parameter. The radius of the silo, 2 meters. The length of the rope would be 2 pi r over 2, whatever that value comes out to be. So we know that number. And then I've got as a parameter, A is the total area she could graze in. Would be a constant, right? The total area she's able to graze in would be constant in this situation. Does it make sense? Anyone dying to share one that I didn't put up there? Yes, sir. The number of ropes is a constant, absolutely. So was there a hand over here? Who else is dying to share one of their constants or parameters? One more. Somebody new. Was that a hand? Okay, come on. Someone's got, oh, there you go.
Starting point of the rope.
Okay, but that's not a constant or parameter is a value. It's going to take on a value, a constant value. So that's a location. Okay, so you could say the x-coordinate of the starting location. There you go. So if you just said the x-coordinate of the starting location, that would be a constant. Was there one more here? Yeah. Good. So the cow's maximum distance that she gets from the silo. Okay. Others. So we good on that. So what about variables? What did you guys come up with for variables? Who wants to share the variables? And that means you have to say a letter. You're going to sign a letter. Yes, sir. Okay, so D equals distance cow is from cow's distance. Gee whiz. All right, now I'm making progress. Okay, so can we be more specific? What do you mean by distance from the silo?
Well, based on the rope curves around the silo.
Okay. Okay. So like perpendicular distance to the silo? Okay. Okay, so D. So I called it D. D equals cow's distance from the silo in meters. Changing? Is it changing? Absolutely. Yes, sir. Speed. Okay, so what do you want? We're defining variables. S equals? Okay, so yeah, so this that's fine. So speed of the cow in meters per second. Okay, what else? So that's changing. Yes, sir.
The total area of grazed land.
The total area of grazed land. And what do you want? Variable you want to call that? G equals amount area grazed in meters squared. How is that changing? How is that changing?
Well, cow could eat something over here on the left.
Yeah.
Be out, but there's more on the right.
Right.
If the cow eats on there, the rest will go
Yeah.
on the left.
So area grazed, so it's like so how much she's eaten at any given time. Anyone else? One more variable you're dying to share? Yeah. Position along the arc. So position isn't a value. So you have to specify what value are you talking about. Do you know what I mean? Position. So variables take on values. Position. How are you going to define position as a value? Okay. So what variable? X equals. What does X equal? How about the number of meters of rope not wrapped on the silo. Did anybody have that one? You had that. Cool. And what did you come up with a domain for that? So the domain is like all possible values that could take on. So the number of meters of rope not wrapped on the silo would be from what? So the domain would be 0 to 0 to 6. So it'd be the total length of the rope, right? It'd be the total length of the rope. And so that was our 2 pi r over 2. So all possible values that x could take on in terms of the number of meters of rope not wrapped on the silo could be 0 all the way up to the length of the rope, 2 pi r over 2. Okay, what's the domain of G? So this variable G, what's the domain of G, the area grazed? Work it out with the person next to you. What is the domain for area grazed in meters squared? What are all possible values that G could take on? Go. Zero to what? You can do it. Why? Because we define that parameter for the maximum grazing area. Hey. So we defined capital A as the total amount that could be grazed in. So that's the maximum area that could be grazed. We defined A as a parameter, so now we can use it. Do you see? We defined A as that parameter, so we can use it to define our domain. How is GC plotting all this stuff? How is GC plotting all this stuff? No, not magic. By my inputs. What's that? Okay, so how is it graphing? It's graphing, what do we learn? Right. He said it's graphing all the points whose coordinates make, so there's an equation for this pink curve. And it's going to, if I put that equation in correctly, it's going to plot every point that makes that true. If I click on the curve, I get crosshairs, I can drag, and it gives me all the ordered pairs that I want. So as I move that, it gives me the current values of x and y of that. And then there's another command line for this graph, for the rope. And then there's another command line for the silo. Okay, so let me just give you a glance at it. So it's not a computer language, it's mathematics. I put the mathematics in, and it just plots every point that makes these true. Okay? Oh, don't be scared. Okay, but it's, again, these are just equations. So here's the rope. Okay? New example. Here we go. Go. So Cerny and Morgan are 22 feet apart when they start walking toward each other. Cerny walks at 5 feet per second, and Morgan also walks at a constant speed, but faster than Cerny. They eventually meet and do their secret handshake. define constants in the situation, use parameters for constants, define variables, state the intervals over which they vary. Go. Yep, Cerny walks at 5 feet per second. Morgan also walks at a constant speed. Any others that you're dying to share? Constants or parameters. So Morgan's speed would be a parameter. The time it takes, the total time it takes for them to meet from when they started walking. That's a parameter. Okay? Variables. Yeah. What's your variable? X equals distance between them in feet. Another variable. Yeah. Who? Right. So we could say S equals Cerny's distance from her starting point in feet. T equals time since they started walking in, nope, seconds. What's the domain of little t? What's the domain? 0 to capital T. That's a parameter. That's a set value, so the domain is from 0 to capital T. What's the domain on X? 0 to 22. All possible values it could take on, 0 to 22.